morning, everybody. This is going to be the first video I'm putting out there, so apologies if the audio or the frame rate looks a little bit weird. We're just trying out a few different things in this COVID-19 epidemic. It's currently Wednesday morning at 8:35, and I thought I'd make a little video here showing you how to do the math around concentration problems, how to figure out concentration and volume and moles and even mass measured in grams for solutions. So this actually corresponds with the concentration lesson. These are the examples that you can find in the Google slideshow in that sequence in Genius. So I'm going to go ahead and start solving these ones, and it's going to be a little bit weird because I'm used to having students in the class chirping and congratulating me on my success in solving these problems, but I don't have that now, so I may say things every now and then, and with the expectation that people will respond or tell me that they don't get it. But if you don't get it, the nice thing about a video is that you can always pause it and go back and watch something that you didn't understand. So I actually think this is a really good advantage of doing videos. You can obviously slow it down, make it go a little bit faster. If you understand the example, just skip ahead to the next one. All right. So I'm going to try to keep these videos to about 10 to 15 minutes long at most. And yeah, we'll see how those go. All right. So let's start with our first example. This example states that we've got some sodium chloride dissolved in water, and it gives us a 500.0 milliliter solution. And we're being asked to solve for the concentration of the solution. So this is actually a pretty simple example because we're dealing with a molar concentration. And molar concentration is also known as a amount concentration. So we're dealing with a molar concentration. So that's a concentration in moles per liter. You'll also see these given as amount concentration. So those terms are used interchangeably. So a molar concentration refers to moles of solute. So the stuff being dissolved. Moles of solute per liters of solution. So we often refer to this as moles per liter. Okay. And sorry, I shouldn't have written that. The units are moles per liter, but in the past we used to be able to say this as M. We used to be able to just say M, something like this. Like capital M meant moles per liter, but I believe the latest changes is like that's not an official thing that we can use to represent moles per liter. We have to use moles per liter. We can't just write capital M anymore. So that might be a bit of a change for me. You might notice that I write capital M after things because coming, I guess, from an older school, even though I don't feel that old. Anyway, let's dive into the example. So what is the concentration of this solution? Well, we just have to plug in our numbers at this point. We know that we have some sodium chloride, so that's just table salt. We dissolve it in water, and that means we have moles represented by N. That's 0.900 moles. And I have a volume of, what's my volume? 500 mils, but of course we need to convert that into liters and keep all our significant digits. So that gives us 0.5000 liters. To solve for the concentration represented by C is equal to the number of moles divided by our volume. if I plug in my numbers, I get 0.900 moles. Over 0.5000 liters. And that gives me a concentration. I'll bring up my trusted calculator. I love this calculator. So I do the math there, that's 1.8 moles per liter. Yay! I'm gonna try to find some way to get some sound effects in here every now and then, just to annoy you. Okay, that's basically that example. The next one in your slideshow is example 2, and I'm gonna try to go a little bit faster. That one took like 3 minutes. I feel like I'm gonna need to go a little bit faster if I'm gonna get everything in under 15. All right, how many moles of solute are in 2 liters of a 0.0025 mole per liter solution of potassium permanganate? So this one's a little bit different. This time we're gonna try to find moles. We're gonna use this formula. So this is just concentration equals number of moles over volume. And this time we have to rearrange it to solve for moles. So rearrange this equation if you're unsure. Maybe keep going and watch me do it, but if you know how to do it, just maybe pause the video, make sure you know how to do it. But most of you should know how to do this at this point. It's pretty simple. Number of moles, I need to multiply both sides of the equation by volume, and I get concentration times volume. Number of moles equals concentration times volume. All right, so now I just need to plug in my numbers. The concentration here is a 0.0025 mole per liter solution, and the volume is 2 liters. And one way that you can check to see you're doing this right, of course, is to do some unit analysis and see if this makes sense. When we do a unit analysis, the unit of my final answer should result from canceling out units throughout my my operations, my mathematical operations. So if we look closely here, what should my units be? My unit should be in moles because I'm calculating moles. And if I look over to the right, I've set things up here. So concentration has units of moles per liter, and volume has units of liters. So when I do this math, it's like doing moles times liters, then divided by liters. So we've got liters divided by liters in there, which really just works out to 1. And the unit we're left with, maybe I'll do this one in green. Green means go, it means good, it means growth. We're working toward the solution. This means my final unit will be in moles. So that's another way that I know that I'm doing this question properly. Let's plug in our numbers. And what do we get? We get 0.005. What is it? What are we solving for? We're solving for moles, of course, and 0.005. And if we want to keep sig digs in Alberta, we should throw in the last 2 numbers. Is that how many sig digs I need? No, I think I'm only allowed to actually have 2 because that one only has 2 sig digs technically. So if I was going to write my final answer, it should look like this. That looks a little bit nicer. And of course, to preserve sig digs, you could always put things into scientific notation. So this one's okay, but you could also write, let's see, how many places do we have to move our decimal place over? Do we go 1, 2, 3 places to the right? So that means it would be 5.0 times 10 to the negative 3 moles. And that way I still get my 2 sig digs in right here. All right, that's example 2. And I think I'm gonna leave it there because now we're at 9 minutes and 55 seconds. I never knew I took this long to solve things. I apologize to all of you. for having to listen to my voice this long in class, but I will try to go faster. All right, I'm going to make another one to cover examples 3 and 4 in the next few minutes. All right, see you then.